So every organic chemistry student knows about some general formulas in organic chemistry, and the most famous of that is the general formula of an alkane, which people call alkane, or maybe saturated hydrocarbon, and that general formula is CnH2n+2. So we will look into this matter and figure out why this general formula is like this. So what are saturated hydrocarbons? So by definition, they are saturated with hydrogen. They are saturated with hydrogens. So a hydrocarbon in which you can't have more hydrogens. You are saturated with hydrogen. The molecule is saturated with hydrogen, not more. It's not possible to have more hydrogens. And of course, without adding any carbon. So here we have a molecule. This molecule is a simple representation of C5. This is a bond line notation in which every corner is a carbon atom. So instead of denoting the molecule like this, like showing each and every atom, it's not required, because one can say that the carbon atoms can be denoted by a corner, and hydrogen atoms, you can understand how many hydrogen atoms are there, because carbon atoms make 4 bonds. So that's why it can be figured out that this structure here is C5. There is C, 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 and if you count hydrogens, you will get 3 here, 2 here, 2 here, 2 here, and 3 more here. So this is C5, and H, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is a saturated hydrocarbon because it's said that in saturated hydrocarbon you can't have more than 2n+2 hydrogens. So here n is 5. So 2n+2 will be 2 times 5 plus 2, that is 12. And indeed you have 12 hydrogens. And this seems like a saturated hydrocarbons. But you might be thinking, why we can't have more than 12 hydrogen atoms? We will see this. We will see this in the proof. But this is a saturated hydrocarbon. Let's see the next one. This is also a saturated hydrocarbons. You can count the number of carbons and hydrogens and you will see that it's saturated. This is also a saturated hydrocarbon. This one here is also a saturated hydrocarbons. It's guaranteed. You can pause the video and count the number of carbons and hydrogen atoms and figure out that the formulas here will satisfy the CnH2n+2 rule. But this new one here is not a saturated hydrocarbon, because here in this you have C, C, like I won't show you all the C's. You can understand that there are carbons here. Hydrogens, let's see, there are 3 hydrogens here because this carbon has only 1 bond. There's 1 more hydrogen here. There are 2 more hydrogen atoms here, 2 more here, 2 here, and 2 here. So if you count, you will have C6 and you will have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C6H12. So this doesn't fit the CnH2n+2 rule, because for Cn is equal to 6, 2n+2 will be 14. But this is 2 less than 14. This is only 12. The number of hydrogen atoms can be increased to 14. So this is not a saturated hydrocarbon. Similarly, you can see these examples, you can figure out these examples. This example here is also not a saturated hydrocarbon. This example here is also not a saturated hydrocarbon. You can figure it out on your own. So why is it that we can't have more than 2n+2 hydrogens for n carbons in a hydrocarbon molecule? Okay, so then imagine you have n carbon atoms, and you have to form a molecule in which you are to have maximum number of hydrogens. So how would you connect these carbon atoms? So you have to connect them in such a way that you can have as many hydrogens as possible. Maximum bonds, you will have to spare maximum bonds for hydrogen. Okay, so how would you connect it? How would you connect these carbon atoms? So let's see how not. Let's first think how not. You must not have any C double bond C or C triple bond C in the connection, because once you have a C double bond C, then you can break it down and add 2 more hydrogens, right? So here the carbon had 4 bonds, and now you can break this double bond. You are not even breaking the molecule. You're not breaking the molecule, and still you can have more than 2 more hydrogens here, right? Similarly, you can't have a triple bond because you can break the triple bond and you can have 4 more hydrogens. So double and triple bonds are not allowed in a saturated hydrocarbon. Also, if you see, you can't have any closed rings, because if you have a closed ring like this, here you can break this and you can have 2 more hydrogens, right? So no closed rings also. Can you have branches? Let's think about this. So this is a molecule in which there are no branches. I have shown this hydrogen because I would like to concentrate on this carbon here and this carbon here. So what I'm going to do now is to this molecule does not have any branch because all the carbon atoms are attached in one straight line, and now I want to create a branch. So what I would do, let's focus on these 2 carbons here, these green carbons, and from here, from the next green carbon, from the right green, the green carbon on the right, I will take up a branch and put it on the left green carbon. As you will see, this branch I will take and I will replace this branch and hydrogen, exchange them, and this is what I get, right? This hydrogen goes here and this branch comes here, and you can notice that in this process number of hydrogens won't change, right? You can notice that in this process number of hydrogens won't change. This is something like 1 2 3 4 5 and 6 actually. 1 2 3 4 1 2 3 4 5 6 7 actually, and this thing becomes like this. You have 5 carbons here and 2 here. So you can count the number of carbons and hydrogens, but they won't change, because what has happened, I have just put this hydrogen there and this branch I have put in place of this hydrogen here. So we can have branches, there is no problem with them. We can have branches, right? Okay, so why is that we can't have, now we come back to the proof. Why is that we can't have 2n+2 hydrogens for n carbons in a hydrocarbon molecule? We saw something that we can't have double bonds, we can't have triple bonds, we can't have rings, but we can have branches. Okay, so now let's come back to the algorithm. We started with imagine like n carbon atoms and how do we connect them. So now we know that we can't have double bonds, we can't have triple bonds or rings, but you can have CC bond only, single bonds only, with or without branches as you wish. So you can have branch or you can also not have branch as you wish. So let's make it simple. I think let's not have branch and see what happens when you connect n carbon atoms in a linear fashion, one after the other, and then let's see how many hydrogens can we have. On the first carbon we can have these 3 hydrogens, on the second 2 hydrogens, on the third 2 more hydrogens, on the fourth 2 more hydrogens, and then 2 hydrogens till Cn-1, and in the last we can also have 3 hydrogens. So 3 hydrogens plus 2 plus 2 2 2 2, and then at last we have 3 more. So 3 and 3, we just have to add this number, how much this number would be. 3 and 3 is 6, and then we have 2n-2 times. Okay, so these 2, they are n-2 times, because you have the first and the last, you counted 3 hydrogens for these carbons, and now what, how many carbons are left? So out of n, you are not counting the first and the last, so in between them there are n-2 carbon atoms. So these 2, there will be n-2 2's here. So instead of adding these 2's, we can multiply this 2 with n-2, and what we get is 2n+2. Okay, so this is why we have this general formula for saturated hydrocarbons. You can't have more than, if you have double bonds, triple bonds or rings, you will always have less than this number 2n+2. So you can't have more than 2n+2 hydrogens. If so, it's not possible. Yeah, there is, like, it's not a complete proof in a way, because somebody can say you only proved us that if there is double bond, if there is triple bond, or if there is ring, there will be lesser hydrogens. So now you are left with only single bonds and branches, and in that case you have 2n+2 hydrogen. So what if there is some another very interesting kind of case in which I can have more hydrogens? So for that, this is like, I leave it to you guys to figure out if you can come up in a way like you can add more than 2n+2 hydrogen to n carbon atoms. Then please let me know in the comment section. Thank you. Have a nice day.